All right, guys, let's talk about rectangles. Our objectives for this lesson are going to be to recognize and apply properties of rectangles. And if we're given a set of information, some coordinates or some data about a quadrilateral, we should be able to determine whether or not that quadrilateral is a rectangle. Let's take a look at our definition here of a rectangle. It's important to know that a rectangle is a type of a parallelogram. We've been talking about parallelograms here in this chapter. A rectangle is a very specific type of a parallelogram. It's one with congruent diagonals. Now, there's probably something else you recognize about a rectangle. A rectangle is a parallelogram with 4 right angles. It turns out it's only at this point when you push your parallelogram into shape, it's only at the point where it gets 4 right angles that the diagonals happen to be congruent to one another. Okay, and this is actually a process that is used in building construction all the time. When you frame up a wall of a house, it might be 32 feet long and 8 feet high, and before you stand it up, you want to make sure that that thing is a rectangle. And to do that, really the only practical way to do it is to measure across the corners and confirm that they have the exact same measure. Confirm that those diagonals are congruent. And at that point, if you have indeed a parallelogram, assuming that we're starting with a parallelogram, which if you built your stud wall with these sides the same length and these sides the same length, then you know you have a parallelogram. And once you confirm the diagonals have the same measure, then you know that your parallelogram is a rectangle. Oftentimes at that point, you'll put a 2x4 across and brace it here, and maybe put a 2x4 across and brace it there so it doesn't rack as you lift it up. And once you stand that wall up, you know you have a rectangle. All right, so our definition here, Theorem 6.13, if a parallelogram is a rectangle, then its diagonals are congruent. In this case, JL would be congruent to KM. All right, let's try a couple of examples. Here we have a rectangular garden gate, which is reinforced with diagonal braces to prevent it from sagging. If JK is 12 feet, I'll just label that, and LN is 6.5 feet. So this segment right here, 6.5 feet, could we find KM? They want this entire diagonal right here. Okay. Well, if it's a rectangle, we know that all parallelograms, the diagonals bisect each other. So these two segments are congruent. But in rectangles, not only do the diagonals bisect each other, but those diagonals are also congruent to one another. So we know these two segments are going to be congruent as well. So if 6.5 and 6.5 gives us a diagonal of 13 here, then we know KM is going to equal 13 as well. All right, let's try another one. Here, quadrilateral EFGH is a rectangle. If GH is 6 and FH, this diagonal here is 15 feet. I'll mark that like that so we know that's the entire diagonal. That's 15 feet. Could we find GJ? Well, a rectangle is a type of a parallelogram, so the diagonals bisect each other. That means each of these is 7.5. And because it's a rectangle, both diagonals are congruent. That means these segments will be congruent as well. And that means GJ is going to be also 7.5. Okay? Well, let's try another one. Here, this is when it gets fun, when we get to mix in a little algebra. Quadrilateral RSTU is a rectangle if the measure of angle RTU, that's this angle in here, if this angle is 8x plus 4 degrees, And the measure of angle SUR, this guy down here, is 3x minus 2 degrees. Could we find x? Okay. Well, what do we know about rectangles that would help us figure this out? We know the diagonals are going to be congruent. We know a rectangle is a type of a parallelogram, so the diagonals bisect each other. And since they're congruent, these two segments will also have the same measure. All four of these segments will have the same measure. And now I'm wondering if you see anything interesting about triangle PTU. This triangle right here. When we draw those diagonals in a rectangle, we end up with some triangles. And what do you see about triangle PTU? That's an isosceles triangle, isn't it? And what do we know about isosceles triangles? We've got two congruent legs, and that means that the base angles located across from the congruent legs are going to be congruent to one another. So these two angles are congruent. So if this angle is 8x plus 4 degrees, so is this angle. And what do we know about these two angles here in a rectangle? That is going to be a 90-degree angle if it's a rectangle. And so these angles are going to be complementary. What does that give us for an equation for solving for x? 3x minus 2 plus 8x plus 4 should equal what? 90 degrees. And when we combine our variable terms, 3x plus 8x, we get 11x. And when we combine our non-variable terms, negative 2 plus 4 gives us plus 2. And we can subtract 2 from both sides here to solve for x. We get 11x equals 88. If we divide both sides by 11, we get x equals 8. Okay? Can everybody see that? All right, let's try another one. Quadrilateral EFGH is a rectangle if the measure of angle FGE, so that's this guy right up here, FGE, this angle in here is 6x minus 5. I'm going to mark that 6x minus 5 degrees. And the measure of angle HFE, this angle down here, this guy is 4x minus 5 degrees. Okay, could we find x? Okay, again, we've got a rectangle. We know these diagonals bisect each other and they're congruent to one another. So they end up creating 4 congruent segments. And now I see triangle GJF. And I'm seeing that that is an isosceles triangle. And so if that angle is 6x minus 5, so is this angle. Okay? And because it's a rectangle, what do we know about angle F? That guy's 90 degrees. So these angles are complementary. These angles add up to 90. 6x minus 5 plus 4x minus 5 must equal 90 degrees. Good. When we combine like terms, we get 10x minus 5 is minus 10. And we can add 10 to both sides. We get 10x equals 100. And if we divide both sides by 10, we get x equals 10. Always go back and read the question again. Did we find what they were asking for? Yes, they wanted x. Now, if you wanted to know the measure of this angle FG, could we figure that out? Well, we can plug x back in. 6 times 10 is 60 minus 5 is 55 degrees. Okay. All right, next idea. Diagonals of a rectangle. If the diagonals of a parallelogram are congruent, then the parallelogram must be a rectangle. Okay, so this is basically how you prove, if you know you have a parallelogram, How do you know whether or not it's also a rectangle? This is going to be your test. You can test to see if the diagonals have the same measure, if they're congruent. So let's try a couple of problems like this. Max is building a swimming pool in his backyard. He measures the length and width of the pool so that opposite sides are parallel. He also measures the diagonals of the pool to make sure that they are congruent. How does he know that the measure of each corner is 90 degrees? All right, let's take a look at each of these. So he's measured and he's found that the opposite sides are parallel. He also measures the diagonals of the pool to make sure they are congruent. How does he know these are going to be 90 degrees? So A, since opposite sides are parallel, STUR must be a rectangle. Is that a true statement? Not all parallelograms are rectangles. So the fact that the opposite sides are parallel tells us we have a parallelogram, but not necessarily a rectangle. So I'm not going to go with choice A there. Choice B, since opposite sides are congruent, STUR must be a rectangle. Well, it didn't actually tell us that they're congruent, but if they were, even if they were, let's go ahead and assume that they are. I guess we do know they are because we know that they're parallel, and then we know it's a parallelogram, and there's lots of things we know about parallelograms, including the fact that the opposite sides are congruent. But that's true of all parallelograms, not just rectangles. So that doesn't necessarily prove it's a rectangle. Since diagonals of the parallelogram are congruent, STUR must be a rectangle. That is what you have to rely on if you're going to prove or disprove that your parallelogram is a rectangle. You've got to know that those diagonals are congruent. Only when the diagonals are congruent do you actually have a rectangle. If you drew a really, really flattened out parallelogram, it would be more apparent that the diagonals are not congruent. Clearly, this diagonal is much longer than this diagonal. And it's only when you push, if you were to push on that and try to straighten it up, you could see that this diagonal gets shorter, that diagonal get longer. And at the point where they're equal, then you know you have your rectangle and you have your right angles. All right, so I like C, and we do have enough information. If he measured the diagonals and he knows they're congruent, then we do have enough information to know that it is a rectangle. All right, next idea. Okay, let's talk about leopards for a second. Here are, I hope you'll agree, these are some characteristics of leopards. They have spots, they have 4 legs, they have a long tail, they have sharp teeth, they weigh less than lions and tigers, and they live in Africa. So hopefully we can all agree that those are in fact characteristics, properties, if you will, of leopards. So I'm going to ask you a question. Is this a leopard? And should we apply our test for leopards? Let's just check really quick. It does have spots, has 4 legs, has a long tail, has some sharp teeth in there, even though we can't see them. I know they're in there. Weighs less than lions and tigers. And does anybody live in Africa own one of these? I suspect there might be 1 or 2 of them in Africa. So is it a leopard? Well, of course, this is not a leopard. The question here is, should we bother applying our test for leopards if we haven't first asked ourselves an important question about this animal? Is this animal a cat? If your animal is not a cat, don't bother testing to see if it's a leopard. And likewise, if your quadrilateral is not a parallelogram, don't bother testing to see if it's a rectangle. If it's not a parallelogram, it can't be a rectangle. So why do I suggest that? Well, if you take a quadrilateral and you check the diagonals and you find they're congruent and you want to jump to the conclusion that it must be a rectangle, first be confident that it's a parallelogram, because there's another quadrilateral hiding out there that could impersonate a rectangle if you're not careful. It's this guy. His name is the isosceles trapezoid, and we're going to learn more about him in the next few lessons. But he has only one pair of sides that are parallel, and he has these two legs that are congruent. And it just so happens in this quadrilateral, the diagonals are congruent. Okay? So before you check the diagonals and conclude that your quadrilateral is a rectangle, first check, is it a parallelogram? First. Okay? First, make sure of that. If it's not a parallelogram, don't bother checking to see if it's a rectangle. It can't be. And if your animal is not a cat, don't bother checking to see if it's a leopard. All right, let's do an example. I'll show you an example here. Here we have quadrilateral JKLM, and they give us these vertices, and we can plot them. They've plotted them for us here. They want us to determine whether JKLM is a rectangle using the distance formula. Okay, so I could jump right in and draw these diagonals and use our distance formula. Remember, the distance between any 2 points equals the square root of the change in x squared plus the change in y squared. Okay, but what if it's not a parallelogram? Wouldn't I be wasting my time? I might inadvertently conclude that it's a rectangle when it's a trapezoid. So can we go ahead and check first and confirm they did not tell us it's a parallelogram? They just told us it's a four-sided polygon. It's a quadrilateral. So let's first confirm that it's a parallelogram. Let's look at the slopes of JK and ML. The slope here, I go up 1 over 3 to go from J to K. So up 1 over 3, that's a slope of 1/3. And going from M to L, my slope, I go up 1 over 3. All right, so I'm happy with calling those sides parallel. That's good. Now I got to confirm that JM is parallel to KL as well. If I go from J to M, it looks like I go down 6 units, 1, 2, 3, 4, 5, 6 to get to here. And then I go over 2. So down 6 over 2, pardon me while I turn this for a second. Down 6 over 2. That's a slope of -3. Good. Let's check from going from K to L. I go down 1, 2, 3, 4, 5, 6, and then over 1, 2. So that is also a slope of -3. So I'm confident now that this is in fact a parallelogram. So could it be a rectangle? It might be. How do I prove or disprove that this is a rectangle now using the distance formula? Well, why don't we take a look at these diagonals? This one diagonal here, I could find the distance from M to K. Okay. And the distance from M to K, I go over 1 and up 1, 2, 3, 4, 5, 6, 7. You'll also notice you can figure that out from the coordinates if you like that other version of the distance formula. Going from 0, x equals 0 to x equals 1, my delta x is 1. And going from y equals -3 to y equals +4, I went up 7 units. So my delta y is 7 units. So the distance from M to K is the square root of 1 plus 49, 7 squared is 49, or the square root of 50. Good. So could we also find the distance from J to L? Let's take a look at that. Going from here to here. My delta x going from, you can draw in this little triangle if you want. It helps. I like to do that. My delta x, I go over 1, 2, 3, 4, 5 units. And you can see the coordinates support that, going from -2 to +3. My delta x was 5 units. And my delta y, I go down 1, 2, 3, 4, 5 units. You can see the y coordinates support that. I idea as well. So my delta y is 5 units. So it looks like this is the square root of 25 plus 25, which is the square root of 50. Are these diagonals congruent? Yes, they are. So we have a rectangle. Now, I'm going to show you another shortcut too. They told you to use the distance formula, but was there a faster way to prove that this is a rectangle? Once you did all that work to prove that it was a parallelogram, you had these slopes, right? This slope was 1/3, and this slope was -3. Positive 1/3, -3. Those slopes are negative reciprocals of one another, aren't they? And what do we know about lines that have slopes that are negative reciprocals of one another? They must be perpendicular. And then remember from our lesson on parallelograms, if you've got a parallelogram with one right angle, then you have a parallelogram with 4 right angles. And what would we call that? That would be our rectangle. All right, that's my lesson on rectangles, guys. Thanks for checking it out, and good luck on the homework.